So, let us start learning the TCP/IP protocol suite. In this video, we will learn to describe what is TCP/IP model, and we will have a brief overview of TCP/IP model. So, what is TCP/IP model? The Internet Protocol is like any other communication protocol, is a set of rules which will govern every possible communication over the Internet. Since the development of the ARPANET, TCP/IP together has emerged as the controlling body. It is being used in the computers of not only in the United States but all over the world for all the types of and sizes of computers. It has become the language of the Internet. TCP/IP are two protocols, Transmission Control Protocol and Internet Protocol. These two protocols describe the movement of data between the host computers on the Internet. This new architecture is known as TCP/IP reference model due to the use of two protocols TCP and IP. So, while designing the new model, certain goals were to be achieved. I will tell a few of them. First was the design goal, which was to have an ability to connect multiple networks together in a seamless way. Another goal was that the network should be able to survive loss of subnet hardware with existing conversation not being broken. And the last one was a flexible architecture was needed to deal successfully with the divergent requirements of various applications. So, the overview of TCP/IP model is as follows. TCP/IP offers a simple naming and addressing scheme whereby different resources on the Internet can easily be located. Information on the Internet is carried in packets. The IP protocol is used to put a message into a packet. Each packet has the address of a sender and the recipient's address. These addresses are known as IP addresses, which we will be learning in upcoming lectures. ARPA originally created TCP/IP to connect military networks together, but later on, this protocol was also given to government agencies and universities free of cost. TCP/IP model is most widely used because it is robust to failures and flexible to diverse networks. TCP/IP became the standard for Unix computers, especially in the military and university environments. With the development of HTTPS protocol for sharing HTML language freely on the Internet, the World Wide Web was born, and soon TCP/IP came into much use. So, let's have a look at the TCP/IP model. In the picture, you can see that I have shown 5 layers, but 4 layers are also used interchangeably. The data link layer and the physical layer is together known as host to network layer. So, the 5-layer model consists of the following 5 layers: application layer, transport layer, network layer, data link layer, and the physical layer. Since the 5-layer model is basically a communication model to be explained in layman's terms, hence I will understand it using a real-life communication example. Now, for the explanation purposes, I will demonstrate it in 4-layer model. Let us consider Bob and Peter are two friends who live in different cities, say city A and city B. It is Peter's birthday and Bob has decided to send his friend a Harry Potter series book as a birthday gift. So in this case, Bob is the sender, that is source, and Peter is the intended receiver, that is destination. Now there are 7 books in the Harry Potter series, say each weighing 1 kg. So Bob packs all the 7 books into an envelope weighing 7 kg in total. The envelope has Bob's address and Peter's address as well. The following is a detailed discussion on how this transfer of books takes place, so please make sure that you listen carefully. Let us see what happens at the application layer. Bob goes to the nearby post box and puts the 7 kg envelope into the post box. Here, Bob's job is finished. Bob does not have to concern about how the postman carries out his job. This part where Bob puts the 7 kg envelope into the post box is nothing but our application layer. Moving on to the next layer. Now, when the postman arrives into the post box, he collects the envelopes in it, along with Bob's 7 kg envelope. But the sorting office only takes in a package weighing maximum of 1 kg. Due to this, the postman does the following. He takes out all the 7 books out of Bob's envelope, puts each book into a single envelope weighing 1 kg, writes Bob's address and Peter's address on all the 7 envelopes. Finally, he deposits all the 7 envelopes to the sorting office of City A. Now, here postman's job is finished. He does not have to concern himself about how the sorting office delivers the envelopes to their discussion. That is, postman doesn't have to worry about the details of how sorting office carries out its job. So you must have now got it. This part where the postman puts each book into different envelope and writes the sender and the receiver's address on each envelope and delivers those envelopes is nothing but the transport layer. Moving on to the network layer. Now, since the sorting office of City A has all of the Bob's envelopes, they have to send those envelopes to City B so that they can be delivered to Peter. But there are some rules that have to be followed by the sorting offices. Like, the envelope must have a postal stamp on it, the envelope should have a proper sender and receiver's address, the destination should be inside the same country as that of the senders. Sending offices make sure that all the rules are being followed properly. Also, to send envelopes to different cities, the sorting office has to take help of a courier service. For example, the sorting office pays a carrier service to carry the envelope to different cities. So, the sorting office now hands over the envelope to carrier service. So this part where the sorting office checks all the rules and hands over the envelope to carrier service is the network layer. And finally comes the last layer, which is a combination of data link layer and the physical layer. Now, our carrier service has got all the envelopes and it has to send them to City B. The carrier service can carry out its job in many ways, like they can carry the envelopes via airplanes, or they can carry the envelopes via bus or via ships. But remember that only one option is taken, either bus or airplane or ship. Suppose it decides to take the air travel option. After the package arrives at the destination of City B's airport, the carrier service delivers them to the sorting office of City B. Carrier service's job is finished here. So, this part where the carrier service takes place the envelopes from one city to another via medium is a link layer. Putting it in order, you can consider Bob as the sender, envelope of 7 kg is data, post box is the front end application, putting each box into separate envelope is nothing but network layer, each 1 kg envelope is a data packet, postman is the transport layer protocol service, sorting office as network layer protocol, carrier service as link layer protocol, and Peter as the intended recipient of data. So, by now you must have understood the complete working of TCPIP layers and how these layers act. So, let us have a quick recap. We saw how TCPIP layers worked and it was a big discussion. So if you haven't understood, you should go and read the again and listen to the explanation again to get a better idea of working of TCPIP model. Make sure that you understand all these concepts very clearly because these are the fundamental concepts in networking. What's next? Now we will see the layers of TCPIP model in technical terms, and we'll also see the comparison between OSI model and TCPIP model.